In the early days of research on black holes, before they even had that name, physicists did not know if the bizarre objects existed in the real world. They might have been a quirk of the complicated math used in the then still young general theory of relativity, which describes gravity. Over the years, though, evidence has accumulated that black holes are very real and even exist right here in our galaxy. Today, another strange prediction from general relativity: wormholes. Those fantastical sounding tunnels to the other side of the universe hang in the same sort of balance. Are they real? And if they are out there in our cosmos, could humans hope to use them for getting around? After the prediction in 1935, research seemed to point toward no wormholes appeared unlikely to be an element of reality. But new work offers hints of how they could arise, and the process may be easier than physicists have long thought. The original idea of a wormhole came from physicists Albert Einstein and Nathan Rosen. They studied the strange equations that we now know describe that unescapable pocket of space we call a black hole, and asked what they really represented. Einstein and Rosen discovered that, theoretically at least, a black hole surface might work as a bridge that connected to a second patch of space. The journey might be as if you went down the drain of a bathtub, and instead of getting stuck in the pipes, you come out or into another tub just like the first. Subsequent work expanded this idea but turned up two persistent challenges that prevent the formation of easily spotted, humanly usable wormholes: fragility and tininess. First, it turns out that in general relativity, the gravitational attraction of any normal matter passing through a wormhole acts to pull the tunnel shut. Making a stable wormhole requires some kind of extra, a typical ingredient that acts to keep the hole open, which researchers call the exotic matter. Second, the kinds of wormhole creating process that scientists had studied rely on effects that could prevent a macroscopic traveler from entering. The challenge is that the process that creates the wormhole and the exotic matter that stabilizes it cannot stray too far from familiar physics. Exotic does not mean physicists can dream up any sort of stuff that gets the job done on paper. But so far, familiar physics has delivered only microscopic wormholes. A bigger wormhole seems to require a process or type of matter that is both unusual and unbelievable. That's the delicacy, says Brianna Grado-White, a physicist and wormhole researcher at Brandeis University. A breakthrough occurred in late 2017 when physicists Ping Gao and Daniel Jeffries, both then at the Harvard University, and Aaron Wall, then at the Institute for Advanced Study in Princeton, New Jersey, discovered a way to prop up wormholes with quantum entanglement, a kind of long-distance connection between quantum entities. I've discussed this in detail in another video of mine. Do check that out as well. The peculiar nature of entanglement allows it to provide the exotic ingredient needed for wormhole stability. And because entanglement is a standard feature of quantum physics, it is relatively easy to create. It's really a beautiful theoretical idea, says Nabil Iqbal, a physicist in Durham University, England, who was not involved in the research. Though the method helps to stabilize wormholes, it can deliver only microscopic ones. But this new approach has inspired a stream of work that uses the entanglement trick with different sorts of matter in the hopes of bigger, longer lasting holes. One easy to picture idea comes from a preprint study by Iqbal and his Durham University colleague Simon Ross. The two tried to see if they could make the Gao-Jeffries-Wall method to produce a large wormhole. And I quote, "We thought it would be interesting from a sci-fi point of view to push the limits and see whether this thing could exist," Iqbal says. Their work showed how special disturbances within the magnetic field surrounding a black hole could, in theory, generate stable wormholes. Unfortunately, the effect still only forms microscopic wormholes, and Iqbal says it is highly unlikely the situation would occur in reality. Iqbal and Rose's work highlights the delicate part of wormhole construction, finding a realistic process that does not require something added from way beyond the bounds of familiar physics. Physicist Juan Maldacena of the Institute for Advanced Study, who had suggested connections between wormholes and entanglement back in 2013, and his collaborator Alexei Malkin of Princeton University have found a method that could produce large holes. The catch in their approach is that the mysterious dark matter that fills our universe must behave in a particular way, and we may not live in a universe anything like this. We have a limited toolbox, Grado White says. To get something to look the way we need it, there's only so many things we can do with that toolbox. The Boomhorn wormhole research continues. So far, nothing like a made-to-order human-sized wormhole machine looks likely, but the results do show progress. We are learning that we can, in fact, build wormholes that stay open using simple quantum effects, Grado White says. For a very long time, we didn't think these things were possible to build. It turns out that we can. Guys, I have tried to briefly introduce the idea of wormholes with this video. It is a thing that scientists are still discovering on, and it is a very detailed video. I do not want it to make you complicated and like scratching your head with this. It's just a brief introduction, but I just wanted to show that this, along with the concept of quantum entanglement, which I have earlier mentioned in a video, can come together and eventually solve the puzzle of space travel in a way that is instant and is not bound by space, distance and time, and we can actually explore any part of the universe without having to actually be in a cryotube for thousands of years and lose every connection that we have with our current civilization on Earth. So this is about it. Please show some love to the original article. I have mentioned the link in the description below. Till that time, cheers. I hope you're enjoying the videos. I'm not going to beg or persist or force you to subscribe or like the channel, but if you feel the content is worth it, then reward it as such. Thank you so much and have a great day.